Okay, when I first read this, I thought it was a typo. And then I looked at his guide and I realized it wasn't a typo. Then I looked it up. I looked up what the function was, all right? Now, granted, I'm not that familiar with all functions that are written down, but this was, I'm not gonna say new to me, just something I couldn't remember. I just couldn't remember it, right? So then I had to realize that this, when the 3 is on that side of it, what does it mean? It means x to the x to the x, right? Kind of bizarre looking, isn't it? And then someone says, what do they want you to do with that? They want you to take its derivative. And this looks really tough to do. So I'll write down, I'll go through the steps I wrote down. I wrote down, the first thing I wrote down is y equals that, right? Then I noticed that what I like to do when I see these power problems is to take the natural log of both sides. So if I did that, the natural log of y, well, what would come down? The exponent, which in this case is x to the x, times the natural log of x. But I still got an exponent problem. So I do the log again. And what's that going to be? Oh boy, that's going to be a tough one, isn't it? It's going to be the natural log of that product. Well, what do I know about the natural log of the product? It's fairly easy to do. Let me put out what I mean by that. So the natural log of x to the x times the natural log of x. Well, logs are easy. What do you get? Log, or natural log, of x to the x plus the log of a log of x, all right? Now, by the way, this x comes down, so we get x ln x plus ln x. Let me show where that's written. That's written right over here. X ln x, and then natural log of the natural log of x. Okay, it's tough, right? What do you mean by tough? I got to differentiate it now, all right? What are we looking for? We're actually looking for dy dx, by the way. So what I do, I look at the left side, and let me point out what the left side is. This is the left side, and this is the right side. And I differentiate. And so if you differentiate the left side, you get, 1 over the natural log of y. You go to the inside, and the derivative of the natural log of y is 1 over y. And then what I do is chain rule, it's dy dx. I got that part covered. Then what am I doing? I'm differentiating the right side now. So what do I see over there? Well, if you differentiate the first term, which is x ln x, you would get x over x plus ln x. All right? Let me show you where that's written. X over x is 1 plus ln x. If you differentiate the second term, which this guy right over here, what's that going to be? Well, we just did it. It's 1 over the natural log of x, and then the derivative of the inside is just simply 1 over x. So I'm good to go. What I mean by that, I'm good to solve for dy dx. How do I do that? Multiply both sides of the equation by the y ln y. So you get this times this side over here, all right? Now, I said there's nothing wrong with that, but I do want to write down what that means to me. So I hope you remember that y is equal to x to the x to the x. And I know what y is. And what's the natural log of y? The natural log of y is x to the x times ln x. Let me show where that's written down. So we got this part, we got this part, and we simplified it. So what do you get over there? We got this, and we got this times this, and we're done. Now granted, it's a tough derivative. A lot of times when you see a function, you have to look it up. There are other problems that I would say are probably even more difficult than this one over here, but it did lend itself to the techniques that we discussed in Calculus 1. Thank you.